Hey everyone, so welcome back to the another episode of the Sway Community Call for the November edition. I'm your host Nazi, and for this session we have a tooling team with us. Firstly, I would like to welcome Joshua, who is the lead of the tooling team, and along with that Zeeshan. I think this is the second time of him with us, and for the very first time we have Kaya from the tooling team. Like these are all the OGs of the tooling team and the minds behind the all the best tooling that you see of the Sway compiler as well as Sway language. So yeah, welcome guys. It's exciting to have you. How you have been?
Thanks for having us. Yeah, it's exciting, cool to have us all here at once. I thought it might make it be fun for us all to jump on the same call and vibe off each other. Since we haven't had a chance to do that yet, so I'm looking forward to today's chat. Yeah.
Awesome. So to give a bit of a jest, like we usually in our regular sessions, like there is a one person demoing, but for today it's a special one. We have the entire team. So for this one, each one of them is gonna be showing and demoing something us that's gonna be quite helpful. So stay tuned for the entire episode, and yeah, let's dive into it. And for the very first session, I would like to welcome Joshua, and would like to invite him to be on the stage. And yeah, stage is all yours.
Cool. Thanks, Z. All right. Yeah. So one thing that we've been thinking about for a while. That actually kind of soft launched a couple of months ago, but we've been working on it in the background. But I thought today would be a good chance to talk about it some more, as it was really built for the community. And the more community engagement we get with this, the better it's going to be for all other developers in the ecosystem. It is a way to actually share packages with other developers and also discover packages. So I
Mm-hmm.
guess if you're coming from the Rust ecosystem, this is possibly what I think is one of the coolest features of Rust is having crates.io and docs.rs, and being able to share packages. And if you need serialization, you just go on to crates.io, search for serialization, and all of a sudden you get to harness all of the crazy work
Yeah.
from talented people, and you don't have to do it yourself. And obviously npm will have package managers, and it's a common thing for languages. And so from the very beginning, for years now, we've always talked about how cool it would be to actually have like a package manager and a way to share packages for the Sway language,
Mm-hmm.
so that people didn't have to rewrite the wheel every time, and people could just bootstrap and get going quickly. So that's what I wanted to kind of just discuss today, and maybe introduce like a little feature that is kind of only a few days old as well. And then, yeah, happy to answer any questions you got, Nazi, that you think that devs in the community might want to hear about.
Sure.
But yeah, I'll share my screen, and I might just start with a quick tour of what Rust does, just as a quick reminder if people aren't familiar. Share my screen. As obviously the Rust ecosystem and tooling and language is very influential to Sway itself, as we really wanted to allow Rust developers just to come in and just feel productive
Mm-hmm.
from day one, as it's so similar. Is my screen showing up there, is it? Yep.
Yeah, it is now.
Nice, cool. So obviously this is Crates.io. Crates is a place where you can find packages. There's nice ones for like the most downloaded, new crates, just updated. You can also search by like keywords and the categories. So you might be
Mm-hmm.
interested in certain types of data structures. You click on this, and then all of a sudden, all of the different crates that have to do with data structures are there. You can see how many downloads it's had. Let's just go hash brown, which is like a cool little hash library that's super fast.
Mm-hmm.
See some information about it, how you can add it to your cargo toml, some code, just basically a readme.md file, and then some stats, which is quite nice. And also, the other handy thing is you actually get links to the documentation here. So for example, you can just go to the landing page of docs.rs and just
Mm-hmm.
start searching for the crate that you're looking for, and then it'll show up, and then you can click into it. that's one way devs do it, but most of the time people just find this little docs link. So when Cargo Publish is run, it publishes up to Crates.io. It allows you to include this line here in your Cargo TOML to get access to that in your next build. But it also builds the documentation in the background and hosts it on the net so that you can have searchable documentation on the net. So this was the goal. This is the dream, to try and have something as nice as this. And we started with this Crates.io thing, or equivalent, and that is fork.pub. So this is fork.pub. This is our version of Crates.io. I'll show you the commands and everything you need to do to kind of get up and running with it. But it is still kind of in its infancy, but we're just getting going. But it is usable. So we can see that we have new packages just updated. You can kind of go through here and browse. If you're looking for something, say, specific, like I know there's this like verified random number. What have I done here? SRC. Reload page. There, so there's some SRCs. I can browse to them, click into it, and then it loads up, which is pretty interesting. There's also some categories and some keywords, which is interesting. So maybe if you're the libraries, you can click into libraries and see all the different libraries that are popping up and all that kind of stuff. Another thing you can do is if you can't find the code anywhere, even though it kind of should populate here, if you put it in the fork TOML, you can go in here and just download the box code directly and put it in. And also you can actually find multiple versions. So if I go back to fork.pub and open up the standard library, go versions, we can actually see that all the different versions of the standard library are here, and you can click into it and browse the documentation and the README and the code for that specific published version, which is quite cool. So the way that you would do this in practice, for example, if we go back to, say, I don't know, this storage encoded. Actually, let's actually get a library, maybe possible. Well, actually, let's just go to GM because that's what I was playing with. So you've got this GM lib here that I'll show you that I just wrote just a GM lib yesterday. Yeah. I can see the version of fork that it was actually published against. And I'll show everybody how we can actually use this library coming up soon. But to actually publish it, you need to log in with GitHub. So I've probably done this already. So I click login with GitHub. It'll ask you to authenticate if it's your first time behind the scenes. I'm not sure why that's not logging in. Maybe I'll just refresh. Yeah, there we go. I'm logged in. And then go to API tokens, and you'll create a new token, and then you'll need to store that token when you actually run the fork publish command, and then that's how you get your libraries up. So what I'll do maybe is just show people how they can actually use fork publish command itself to get packages up onto the registry. So I'll switch screen shares. Just give me a second.
Sure.
Okay, let me know when that's arrived. There we go. Okay.
Yeah.
So fork publish is actually distributed by FuelUp. So what you could do is go FuelUp show and just make sure that you can actually see fork publish showing. If it's not, then just run FuelUp upgrade, and then that'll pull down the latest version of FuelUp and give you access to fork publish. Once you have that, then you want to sort of CD into your actual project. Then you can just run fork publish, and then this is where you paste your token here.
Yeah.
And then that would actually publish that up there. But before you start publishing things up there, it's probably pretty important to understand what kind of information you can provide. And that's specified in the fork TOML. So I thought I'd just pull up the fork TOML for the standard library here, just so we can have a look at what's included. A lot of these are optional. So you'll notice that we've got ones for like the repository, homepage, and even documentation.
Yeah.
So prior to a thing I'm about to show soon, you could host you could build the documentation using ForkDoc
Yeah.
yourself and host them anywhere on the net. And then this is where you
Mm-hmm.
could direct people to browse the documentation. But we've just added a feature that does this automatically in the back end. So unless
Mm-hmm.
you specifically want to point it to your own hosted documentation, you can now just like leave this blank, and
Okay.
ForkPub will build it in the background and generate and host all the documentation for you, which is cool.
So,
Uh,
like you just need to specify the fields over here, and the registry backend will automatically pre-populate and like the entire page for you behind the scenes.
that's right. That's right.
Perfect.
Um, and then it's probably useful to put categories and keywords, so just for
Mm-hmm.
searchability. But yeah, and the important thing is you want to actually include the version as well. I think that's a requirement.
This is fork version.
This is the version of the actual library that. So in this instance, the standard library and fork versions are the same. But I'll
Mm-hmm.
go to like an easy demo, like this
Mm-hmm.
GM lib that I showed you before. So you can see here I've got my name, the name of the actual library, and then the version here is 0.1.2. I've got a little
Got it.
description here and added some keywords. So you don't actually need to do keywords, but this is
Mm-hmm.
kind of like the MVP of what you'd want to have populated in your fork tunnel before you start
Yeah.
running the fork push command.
Mm-hmm.
And the actual library itself, it's very straightforward. It simply just returns GM or GN if you call
Yeah.
this call these functions. But I wanted to just demo really the documentation part of it.
Mm-hmm.
And so obviously people who are coming from Rust are used to these like top level module comments.
Yeah.
And so you put these at the top of your module, and then it'll use that at the top in the description. And then these are doc comments that happen on hover strings and things like this. So here I've got two functions. They both have doc comments, and we have a module comment. And so if I run fork publish on this, then
Mm-hmm.
we can see it in fork pub, and I'll jump back there in a second.
Mm-hmm.
But the important thing to note is that this is actually 0.1.2 GM. Now, if I
Yeah.
actually found that on ForkPub and I wanted to use it, here's like a little example where
Mm-hmm.
I want to use that in a project. So beforehand, you'd have to open up a fork tunnel and include a reference to the GitHub library where that
Yeah.
library was. Now you can simply just like reference the name of the library that you found and have the version number, and then behind the scenes, Fork will pull in that dependency into the build process and build it all
Yeah.
for you, which is a lot nicer.
Yeah. It's quite impressive.
Yeah, very simple, basically identical to how Cargo does it. And then
Yeah.
to use that, you just basically just call into the public functions. If I go to definition, you can actually see that this file is actually in the registry in the .fork hidden folder at my root directory. So that's all there. And yeah, that all works. So maybe I'll just jump back to fork hub so we can actually see what happened there when I ran fork publish. So jumping all over the place today. Share screen. Okay, so if we actually open up that let the GM lib in fork pub, we can actually see the version here, which is what you'd use in your fork tunnel. But we can also see that this documentation field now has been automatically generated.
Yeah.
And it's got a URL to where the documentation is. So if we open that up and go here, now we can actually see that behind the scenes documentation has been and hosted for your library, which you can then browse if you're trying to understand how it works, rather than having to build fork doc on it locally, or share it on the forum if you've got a question, or share it with friends and stuff like this. So that's kind of the big new feature that landed a few days ago. That you basically get documentation built behind the scenes for you and included here. Similarly, if you're on this URL and you want to access the docs, then you can just go fork.pub/docs.
Yeah.
So before So here you can see that the package. You can get rid of that and just put docs and the version number. But maybe that's a bit too confusing for now. Still, you can you just click on this link for now.
Yeah.
But what I do want to say is that its documentation is built for every version. So if you're using a specific version, say 0.1.1,
Yeah.
and have different docs, you can go there and actually change the documentation here to 1.1, and it'll load the docs for version
Yes.
1.1 as well. So you
Yeah.
should always be able to find the documentation for the version of the library that you're using.
Yeah.
Uh,
So I have actually a question over here. So in the doc section, is it like is that like the docs for every library that I published, even for the ones that have the documentation link attached, or it does not appear like populate over
so
here?
yeah, so it'll only build the server will only build documentation for packages that are published from 3 days ago onwards, because that capability wasn't there 3 days ago.
Mm-hmm.
So any packages going forward that are published, even with the documentation field populated in fork tunnel, will still have documentation built in the background.
Okay.
But the only difference is that you can override this automatically generated one with your own
Got
hosted
it.
documentation if you'd like. But we will still build the documentation, and you can still access it via this same sort of link if you wanted to.
Hmm. Got it. And the version history, like the documentation version history, so does it store for the like uh the one that is overridden, or like the one that is for the default that is generated?
Sorry, can you ask that again?
Yeah, so let's say like I have the custom documentation link that I have overridden. Now, if
Yep.
I like go
Yep.
back to the in the version, does it like stay there? Like, does it store that as well?
Yeah. So if you had an override for 1.1, then it would use override. But if you then remove that for 1.2, then it would use the new auto generated link.
Got it.
Yeah.
Yeah, that makes sense.
So yeah, that's kind of the main parts of it. Obviously, we still want to add things that Crates.io does, like showing dependencies and showing, like the other code that relies on this upstream. That's coming soon.
Mm-hmm.
But I think this is only going to be as useful and cool as the community makes it.
Yeah.
Obviously, internally, we've swapped over to it to publish the standard library and all of the SRCs, for example, and all the Sway libs.
Mm-hmm.
All internally are now accessed and published internally here. But it's it'd be cool to see the community kind of pick this up, and if they've got a nice library that they built in house that they think is generic enough that could be cool to open source, then yeah, feel free to
Totally.
publish it up here and tweet about it, get some credit on crypto Twitter, and yeah.
Yeah. Yeah, totally. Like just tag me or the Swayland channel or even the like Build and Fuel channel or any of the few members, and we'll be happy to support you and guide you.
Absolutely.
Uh,
Yeah, the one thing I'll
yeah.
finish with is for future work here is at the moment we currently only support publishing and building libraries. Or actually, no, sorry, you can publish anything, but we only build documentation for libraries. But we're currently working on also building documentation for contracts, predicates, and scripts,
Mm-hmm.
which will also be handy. But that's coming soon, and yeah, that's probably most of the updates for that feature.
Yeah, that sounds quite exciting. I am like quite excited like to try those on.
Nice.
Uh,
Yeah. Well,
yeah.
yeah, keen to see people make some cool packages.
Yeah,
Maybe
totally.
I'll pass it over to someone. I'll go Kai. He looks pretty excited, so I'll hand it over to
Yeah.
Kai next.
Sure, sure. Um, cool. I'm gonna talk about something upcoming.
Mm-hmm.
So we're gonna be having a fuzzing feature in Sway. So I'm gonna talk about that. I'm gonna briefly talk about what is fuzzing for people that is
Mm-hmm.
not, uh, you know. Yeah,
Yeah.
let's start with it, I guess. So let's talk about fuzzing first. So
Sure.
the goal of yeah, do you have a question before we
No, no, no.
start
Please
or?
go ahead.
Okay.
Yeah, sure. Yeah, sure.
Okay, so the goal of fuzzing, right? What is fuzzing? First of all, the fuzzing is like as simple as it is. It is like automatically finding out this interesting inputs for a function to expose
Mm-hmm.
these interesting behaviors, right? The interesting here means something you probably don't want to happen, right? Like I don't know, like a security vulnerability or something else that you don't want to ever happen. So generally,
Mm.
what you do is that you write tests, right? You write unit tests,
Yeah.
you write other tests, so that these you basically test against some predefined state, right? You say, okay,
Yes.
let a equals to true and let b equals to false, and if I call this fuzz with params, and what happens? You write tests like that. But
Yeah.
in
Like you
fuzzing,
assert it to
yeah,
something, right?
yeah,
Yeah.
yeah, yeah. So in fuzzing, in you're not like actually providing the inputs, but you're trying to get the inputs automatically populated for you, such that it exposes if there is something wrong with the function, it exposes
Mm.
that, right? So like I have a really dumb example here. Let's say
Yeah.
that you have like a function a and b as the inputs. If a is true, you do nothing of interest, right? You, I don't know, do, or like you do something that is not weird, or open to security vulnerabilities, or like if b is true, the same thing happens. But if it's not the case for both these true case, then there's something bad going on, right? And if you're writing tests manually, then there's like this possibility that you tested, this code path, which is, if A is true, and or this code path, which is if B is true, but you didn't test this case, right? So with fuzzing, we want to automate this so that this is also like exposed, and we want to enable this in Sway so that it is like possible to expose these things, like
Yeah.
explain like these things in Sway and use it in Sway. So yeah, so as I said, right now in Sway we can write tests to make sure the code is properly working for a defined input state, right? You can
Mm-hmm.
define the input, and you can make sure that the function is working properly. Or the problem is, as we said, you are, as a human, you will be missing these cases, these edge
Yeah.
cases that you didn't test for, right? You don't have a test for. So with fuzzing, we want to the goal is like checking this large amount of possible input states, so that if to see if there is something that is causing an issue, and you want to
Yeah.
do this automatically. Yeah, so as of today in Sway, you can write unit tests in Sway with test
Yeah.
attribute. This has been the case for, I don't know, like last 2 years, I think. And then you also can write tests using the Rust SDK, right, for the Sway
Mm-hmm.
contract using Rust.
Yeah.
This is also possible right now. And you can, if you want to do it, you can also write
Mm-hmm.
this type of something like a fuzz test, right,
Mm-hmm.
in Rust for your Sway contracts, with using Sway. Like, since you can write anything with
Yeah.
Rust, right, you can write the same kind of logic, which is very convoluted, but you can do that. But
Mm-hmm.
basically, you can't write like this fuzz test. Like you can have them natively in Sway right now.
Mm-hmm.
Like you have the unit test attribute at the
Yeah.
moment.
Yeah.
So what we want to build is, actually, we want to include this in Sway in fork tooling, so that it is easy, and is like, we are like, you want to encourage people to use this, so that this is a good thing to use, right? Because of
Yeah.
security practices. Yeah. So we have a currently open RFC for this process,
Mm-hmm.
and this is not by any means, I guess, not set in stone. How we gonna be, uh, like expressing this fuzzing in Sway.
Mm-hmm.
But it is more or less gonna be probably looking something like this. So I wanna give an example so that it's like more concrete in people's mind. So
Mm-hmm.
what's gonna happen is that so you have this function that you wanna fuzz, right? And like you write for tests, you will have this fuzz attribute that you could put on the function, and which would automatically understand, okay, you want to fuzz this function, and then populate this input with some strategy that I'm going to discuss in a couple
Mm-hmm.
slides later, so that you will get a bunch of different input values, and you will be writing like assertions here, right? You want to make sure that this result is either I don't know, larger than 10, something like that, right? You want to make sure this
Mm-hmm.
result doesn't do this weird thing that you don't want to do it. You
Yeah,
don't
like
want the result to go right.
yeah,
So what will happen is that the fork will automatically do this for you rather than you going and writing, a bunch of individual unit tests
yeah,
with this different input values.
yeah, and asserting to different like test cases, like different situations.
Yeah, yeah, exactly. So you would be, as a developer, you would be writing the assertions for sure,
Hmm.
but the writing the inputs part would be automatically done
Yeah.
to some extent by fork, right? But like as you can imagine, this is a very small example, right? This is like a toy
Hmm.
example, and what people use in real code is going to be much more complicated. So you want to be more expressive than this, right? Sometimes you want to say,
Hmm.
okay, I know that this input is not going to be smaller than 10. I know that it's not going to be larger than, I don't know, 500. You have this
Yeah.
information about the function that you write, and you don't want to test the other cases because it doesn't make any sense to it will, you know that it won't reach those cases
Yeah.
somehow due to your, I don't know, um, business logic, let's say.
Yeah.
So what what are we thinking about for this case is that we will be like providing you these options to tune the fuzzer in some way that it is not wasting time on the input sets that it generates,
Yeah.
like these where these input sets are not sensible, or basically not sensible for your use case, right? So we would be
Yeah.
having, I don't know, you can like say, okay, I want to see the if it's a random number generator based fuzzer. You want the maybe you want to see the random number generator. I don't know, like you want to expose a minimum value or like a maximum value, right? You want to have this details about the parameters for your
Yeah.
function, so that the fuzzer is more guided in the sense that it's like searching the space that you know that it is the case that it will happen in
Hmm.
real life. Uh, so yeah, so little bit of details about, I mentioned this strategy thing in a couple slides back.
Hmm.
Uh, so I want to describe that a little bit. Okay, so before that, let's remember what's the goal of the fuzzer. It was the finding the interesting state, right? So
Hmm.
one really straightforward way to do that is doing it fully randomly without any guidance. Like if you go to the example again, this example maybe,
Hmm.
we can make fork, randomly select input values, and
Yeah.
as in between, minimum number of U64, which is 0, and the maximum number of U64. And
Yeah.
we can run this randomly again and again and again, and to see if it's like adhering to your assertions here.
Yeah.
So this is one case, one possible way that we could implement this randomly, full randomly. The other way that we are thinking that maybe would be useful as like a follow-up implementation after we land the
Yeah.
first implementation with the fully random, fuzzer is gonna be something like, we can do better, right? We can do
Yeah.
we know something about the code, right? For example, I want to show this example here, right? So we have this weird code right now, which is very ugly, but it shows the case very like cleanly.
Hmm.
So let's say that, okay, if all this weird stuff happens, then there is this the bad state happening, right? So if you have like a fully random fuzzer, for this specific toy example, I bet it will find it
Hmm.
in no time. But let's say that for the sake of the argument, this is more convoluted than it looks like, right? Let's say that
Hmm.
inputs are not U64, it's like a
Yeah.
custom data type. I don't know, like it's like a larger code. Um,
Hmm.
but the thing is, you have this information here, which is, okay, so for taking the first if, input needs to be larger than 10,
Yeah.
and then you already explored the code paths coming up until this point, which is nothing. There's no code here, but
Yeah.
you know that if I make the input larger than 10 after some random trials, I will be taking this if, and I will be exploring a new path here, right? So we could
Yes.
use this information to guide the fuzzer a little bit more clever, which is going to be
Hmm.
coverage guided fuzzer. There are like a bunch of implementations in the literature in like real life usage, which is like AFL, very well-known fuzzers that uses this technique in for like C++ and other languages. So this is basically more like a little bit more clever, and still generating randomly, but trying to select these random numbers in a way that um, in the previous iteration it led you to a new path of exploration. For example,
Okay.
you tried, let's say, input is equal to 5, input 2 equals to 10, let's say.
Mm-hmm.
In your first trial, you will not get into this if, and because of that, you will just exit, right? Because input is 5, input
Yes.
is not 10, larger than 10. And then let's say that you tried randomly. Input is equal to 11. Input
Mm-hmm.
2 is, I don't know, something else.
Mm-hmm.
And then you will see that, okay, if the input is 11, then I'm taking this if and I'm exploring more code than I did before. So in the
Yeah.
next iteration, the code, the fuzzer will know that, I need to select something like 11. Like it will select 11 again for the input so that,
Yes.
it can go deeper and deeper. So this is the guided fuzzer. That's probably the
Mm-hmm.
second thing that we want to get to once we have the fuzzer implemented properly.
Mm-hmm.
As we discussed, and the final phase would be, and we are like still trying to whether we should do this or not, but it's like this more clever way of doing this, which
Mm-hmm.
is we can use this SMT solvers to reason about the code, and try to select the inputs more cleverly than even more clever than the coverage guided fuzzer.
Mm-hmm.
So we could say that, okay, so there is a symbolic value called input,
Mm-hmm.
and if it's larger than 10, this is a condition, right? And then there's
Yeah.
another condition called input modulo 2, right? So we could send these values to a SMT solver, and the solver will be giving us a set of values that will satisfy these results. So it will give us something that is both larger than 10 and
Mm-hmm.
also even, right? This is input
Yeah.
modulo
Even.
2 and even. So it will be giving us these like specific things that we ask for. So we can use we know what's going on these like if statements, and we can use this
Yeah.
information to make our decisions even more guided. Yeah, we can say, okay, let's first take the if. For taking the
Yes.
if, we need to invert this if statement. So input needs to be smaller or equal to 10. So we
Mm-hmm.
send this to the SMT solver. SMT solver gives us some value like 5, and we run the test. Easy, nice. We
Yeah.
export the not take if path, and to take the if path, we again do the same thing, but send this case to the SMT solver and get the value like 12 or something, right?
Mm-hmm.
So basically, we can do this, more guided thing, and probably it will be the last phase of our implementation. But yeah, it's something that we are also like eyeing. Yeah, so currently the RFC is up for fuzzing. So if you have any comments on the syntax, on how which path to go, and any preferences, like we are open to all discussions. So please go ahead and leave your comments. And yeah, thank you very much.
Yeah, thank you so much for the amazing presentation. So like for the community, like the link for this RFC will be in the description below. You can check it out there. And I had a question regarding the
Sure.
different phases of fuzzing. So like as we gradually advance on the different categories and like the final stages of fuzzing, how do you think it will uh, affect developers, or like how their tasks will be like improved, like what would be the how, difference in the workflow?
Yeah, for sure. So the main thing is, so for simple contracts, I will guess this only the random fuzzer would be powerful enough, right?
Mm-hmm.
But for more convoluted settings, it's not going to be powerful enough to cover all possible input states in a reasonable amount of time. Like you would need like waiting, couple hours maybe. I don't know,
Mm-hmm.
depending on your complexity of the contract. So these other options are going to be probably more suitable for the cases that you have more convoluted contract settings, like you have a more bigger code base, something like that.
Mhm.
So it is not that the output that they see is gonna be vastly different, because the output as at the end is, as we said, it's just
Yeah.
finding the interesting states, right?
Yeah.
So if you run this randomly number generator based fuzzer
Mhm.
like enough time, then you would actually hit those cases that you would be finding with these two other more advanced cases. So the upside here is that we are expecting to see for more complex contracts, it's going to be faster to find these example interesting states with the advanced implementations that we discussed here. But yeah,
Got it. Yeah, so like with the multiple advancement or the each advancement, the person or like the developer can spend like less and less number of time with the more interesting test cases, like the findings from the fuzzing.
yeah. For the convoluted cases, for convoluted like contracts, that would be the case. That's our guess right now, because we don't have the implementation and benchmarks. But yeah,
Mm-hmm. Awesome.
um, yeah.
Yeah, that sounds super interesting. I can't wait to like try it once it's live. And yeah, like also like this like the one mentioned like uh would be fascinating to see different benchmarks we hit with the each advancement.
Yep.
So yeah, thank you so much for demoing us and like showing us the entire plan. And with that, I would like to move on to our third member from the tooling team, that is Zishan. And I would like to firstly wish Zishan a very happy birthday. Today is his birthday. And yeah, like I hope you had a great one.
Cool. Thank you very much. Yeah, I've had a decent birthday. Luckily, the company gives a birthday leave, so yeah, that's awesome.
It's like
Awesome.
birthday emojis that we can be launching here. I'm trying to find them.
Yeah.
Yeah.
It's not Google Meets, unfortunately.
Yeah. I was looking for that as well.
Awesome.
So yeah, firstly, like exciting to have you, and thank you so much for like sparing time on your birthday evening. I know like it's not like the best thing we like to do, but yeah, I appreciate like taking time on this.
That's all good. No, it's always exciting to present the stuff that we're doing here. So yeah, actually
Yeah.
keen to present this. So just to kick it off, I have been working on, as part of the tooling, state forking functionality in fork node. So fork node
Mhm.
is a way to run a fuel core node in a much simplified manner. And we've introduced, or I'm introducing, as part of the team, state forking. So you can
Mhm.
pretty much point a local node to a remote node somewhere. It could be another local one or something that's running, like the testnet or mainnet, and fetch the contract state dynamically at runtime and query against it or update it locally. So it allows you to
Mhm.
test something that's not on your local machine. Well, something remote, but get it locally and just run it like it's your local contract. It's heavily inspired by the state forking that's in Anvil. So Anvil is the foundry
Mhm.
tooling for Ethereum. So that's something that we're trying to achieve here, just to ease testing and debugging. I will
Mhm.
share a quick. It can get quite technical, so I'll just share a quick demo and maybe
Mhm.
some documentation or diagram of how this is working, and then I'll give a small demo. So
Mhm.
I'll just share my screen now.
And by the way, just to give a little bit gist what the fork node. So earlier, like before, like a year ago, maybe we used to have like that this 11 lines of like big command just to like start the node for the testnet or like mainnet. But now you just need to like run fork node and the network name testnet or mainnet, and you are good to go. It's that simple.
And also you can extend it as well. So it gives you the flexibilities of running fuel core, but also keeps it simple as well. So yeah, it's a
Totally.
great way to run the node. The node. You
Yeah.
can see my screen, right? This is just a mermaid.
Yeah,
Yeah,
I
you might
can.
want to. Yeah, definitely small text.
Yeah,
Oh,
yeah.
okay. I think this text can be ignored or not. Well, I don't know how to ignore it though, but maybe
That's
just
all right. As long as the mermaid diagram's big enough, that's fine. Yep, that's all good.
Yeah, that's perfect.
yeah. So basically, when an RPC request comes in, I think everything boils down to RPC requests. So when you're getting the state of a contract on some UI or updating a contract state, they go through RPC requests. So that when they come into a node, we will first check that is forking enabled. So is this node pointing somewhere? And if it's no, then you use the state that the node already has, which could already have contracts deployed to it and whatnot. But if you have the node pointing to somewhere else, then you check whether the data is in the local database. If it's found, then you can read directly from the database. If it's not, then you would fetch from the upstream fork, and you get the data and then cache it and store it locally in that node. And then after that, depending on the transaction type, if it's well, this is an ETH call, so this is an example of animal, but the same thing if this is like a reading state functionality, you would you would run the state read against the local database and then return the transaction result or the receipt. Or if it's an updating of the state, then you would only update the local node that's running, not the remote one that you're pointing to. Make the state changes there, and then get a receipt back, and then return the result to the user.
Nice.
Yeah.
So, sorry to cut you off here. So, like, let's say if I have made some changes in my local local node, and if I want to like have that exact replica on the like remote, is it possible to like just push it changes like there?
No, you
Like that?
can't upstream the changes, unfortunately, because this is meant for local debugging. You'd have
Okay.
to you have to make you would need to make the calls again on the remote node that you've made locally to get the same changes.
Got it.
Yeah.
Makes sense.
So I'll give a small demo of this. If anyone has any questions, feel free to ask as well during the demo.
Sure.
I'll make the text bigger first, and I'll show what we're doing here. So we're just gonna this is the contract we're going to be deploying. So it's a simple Sway contract with a counter and some ability to read the count and increment the count. And we'll first of all just run a normal fork node. So which is here. So what we're doing here is we're running fork node using local. And we are pointing to a custom database. So we're creating a database from scratch. We have historical execution enabled. So this is required for state forking to work, which I think the testnet, from what I've tested, the testnet and the mainnet nodes have this enabled. And we're going to be running this node on port 4001. So this is just a normal node that's running maybe remotely or locally as well. In this case, we're going to be deploying this contract onto this node. So which is just a simple fork deploy, the default account, and we've deployed it to this address on this node. I have a script that will sort of show what we're planning to do here. So and this is a basic bash script that deletes some stuff that's not needed. So in this script, we have a contract address we've defined, and we're simply performing RPC requests against the node. In this case, this is a node running in the port. That's the contract address, and then this is a query to get the bytecode, and then this is a query to get the contract state and storage slots, and this is another query to get a specific storage slot. And then we have another query using this. This demonstrates using tooling. So existing tooling, like for call, for example, can be used on the node to get some retrieve some state.
Yeah.
So this is already works out of the box right now, right? We have no state forking running right now, but this is just to show that a base case, right? So we're going to be testing this against the node which I've run before. And what you would expect is, oh, it's building. Okay, what about that? Let's let it build. So over here, we have the first query that goes through, which is get the contract bytecode of the contract. Then we have storage retrieval. Well, it's happening twice. And then we're using fork call to get the current count, which is 0 because we had initialized just deployed the contract right. So the initial
Yes.
that is 0. And now what we're going to do is test this against a fork node. So in this case, we'll run another node, and we're going to be running a fork node, which points to the same node, but
Mm-hmm.
we can provide an additional parameter, which is the fork URL. And in this case, this new node will be pointing to the one that we had deployed before, right?
Okay.
And so what we're demonstrating here is that this new node should be able to run through the same script, so query the same contract bytecode and state, even though the
Mm-hmm.
contract is not deployed to this. So it sort of illustrates that we can treat this new node as your local node that you have as a remote node, and perform transactions or get state against it. Before I do that, I'll just make another run the script again. So in this rerun that we'll do, we'll just update the state of that initial count. So this count that's there, the counter count, +2 +4. That's what's happening in the script here, which is shown by this line over here. So we're just running this, running the script here to update the count. Let me just run that once again. The result is still 0, but if we now comment this code out, and if we get the state again, the new count should be 4, right? So this forked, the original node has a contract deployed that has a count of 4. And now we're going to run this test against the forked node. So this one here now.
Yes.
And this is running on. Oh, sorry. Do you have any questions?
No.
Okay.
Just want to just clear things out. So the new node that we have deployed it uses the memory or the state from the previous node that we had deployed our contract to, right? And
so
it's making the query to that.
Node. Yeah, that's right. So it's pointing to the first node, which is running over here, which has the contract deployed to it. But we haven't deployed the contract on this node.
Yeah.
What we're showing here is we're fetching the state of the contract that had been deployed on the original node from this new node. This shouldn't work in theory, but since the fork stating functionality is what enables this to work.
Yes.
So let's run the script against this new node, and if you run it, we should get the same output. So that's the bytecode. This is the storage slot, and we have a result of 4.
So that even though we had initiator the change the state in the previous node, it has been reflected in the new node that we have not even deployed the contracts to.
That's right.
The fork feature
itself has been fetched, and also the state as well. The latest state has been fetched. And the thing that we can do here is we can also, for example, let's enable this. So this should be an update to this state. So if you run this now, we'll update the state from 4 to 8. So we'll just run it again to get the state again, and it should be 8 now. So this forked node has forked off in its state as well. So now, so for example, this node, we've updated the state of the forked contract on this node from 4 to 8, but the original upstream node will still have 4.
4, so because upstream has not reflected the new changes that we have in the new node.
That's right. Yep. So at the point at which we make an RPC request to fetch the state of a node from any tooling, it could even be a curl request. That's the point at which we fetch the contract state and bytecode and save it locally. And all future or subsequent requests from then on will be operating on the forked state.
Got it. So I have a question over here. So is it the case we can only fork and or update the stage from the remote node while we are forking it, or we can also do it in the future, once we have forked, or refresh the memory from the remote node? Is it possible?
You can always run the node again, and we can probably introduce additional flags to refresh the state if you want to. So that is something we can add on to, which is maybe a good feature.
There might be two situations. Once the in the local node the data has been updated, then or let's say now we had the 8 count, while in the remote node it was still 4. So whether it would revert back to 4, or it will ask you the memory has overridden or something like that.
We can we can have 2 different states and maybe refresh the state. The main usefulness of this functionality is for example, when you want to test an arbitrage or a swap before it happens, right?
Hmm.
So you can, for example, just fork the state of the mainnet of a pool when the liquidity is a certain amount,
Hmm.
and then run like local tooling or bots or transactions against that. And it should ideally all run locally and give you receipts and transaction hashes and output as if it were running, as if you're running against the mainnet state, right? Or you're running in the mainnet state. So that's the main benefit of having this forking functionality.
Yeah, and I believe like this was like the most awaited one from the developers, like and this is I think this is gonna be the most useful one. So yeah, I'm excited to like uh try it and like see how it goes. Uh
Awesome.
so
Yeah, I'm also looking forward for people to try it out and give some feedback and maybe shape the future iterations of this. So I just forgot to present again that right now this is still in active development and review.
mhm.
So we have a PR open. Maybe that can also be linked in the description too or
Yeah,
something.
I
The
I put
inspiration.
that.
Okay, nice. And the inspiration is from this RFC that we have as well. So if anyone wants a deeper look, then they can visit the URLs and
Perfect.
read into it. Awesome.
Perfect. Yeah, that brings us to the end of the session. This was the really productive one. A lot of good insights and lot of food that we have been cooking. So yeah, I'm quite excited and I'm actually quite bullish on Sway, the way things have turned out. So yeah, thank you so much, guys, for joining us today and presenting all the amazing toolings. And before signing off, I would like to mention that the new website for the Swaylang is live. You can just head on to swaylang.org and you can find it there. And yeah, that's a wrap. I'll probably see you in the next one in the last month of the year. Until then, enjoy the DevCon and yeah, see you next one. Bye bye.
Thanks, everyone.
Awesome.
See you
Thanks,
later.
everyone.
Thanks.
See
Bye.
ya.
Bye.